All right, so in this video, we're going to talk about the properties of equality. So we can see that Marvin solved this equation, 4 times x plus 5 equals 88. We're going to use the statements to explain each step in his solution. Our job is to fill in the blank with the correct statement to explain each step in Marvin's solution. Each statement may be used once, more than once, or not at all. So we can see down here we have this different steps that Marvin took to solve this equation. We know the explanation for the first step, which is that's the given equation. But then as we go down through, we have to give reasons for how he went from one step to the next step. Our different reasons he used the distributive property. He added 20 to both sides. He added 4 to both sides. He subtracted 20 from both sides. He subtracted 4 from both sides. He multiplied both sides by 20. He multiplied both sides by 4. He divided both sides by 4. He divided both sides by 20, he divided by both sides by 4. So, best way to do this is to, number one, know your properties. Number two, let's go ahead and solve this equation and think about what we're doing. So, to get from step 1 to step 2, we need to think, okay, he went from 4x plus 5 equals 88 to 4x plus 20 equals 88. So we can see that the 88 stayed the same. We are consistent there. That has not changed. But we all of a sudden went from having parentheses to not having parentheses. So if I think about what Marvin actually did, if I have this equation, 4 times x plus 5 equals 88, maybe I remember, if I'm thinking about it, I'm distributing. I am multiplying 4 times x and 4 times 5. That's the distributive property. So I have 4x plus 40 equals 80, or no, plus 20. That's a mistake. 4x plus 20 equals 88. 4 times 5 is 20, not 40. And so we know that he used the distributive property to get from step 1 to step 2. So he used the distributive property. All right, now we're going from step 2 to step 3. He went from 4x plus 20 equals 88 to 4x equals 88. So on this step, we can see that we are consistent with keeping 4x, but clearly the 20 moved to the other side, or moved away at least, and 88 turned into 68. So we have to think, how did he do that? Well, you can't just make something disappear. If he made it disappear, the 88 wouldn't have changed. So let's think more about what actually happened. To make something move, we have to do the opposite. So instead of adding, we had to subtract. And I think that's the only way for the 20 to turn into 0, which then leaves us with that 4x on the left. And then 88 minus 20 is 68. So he subtracted 20 from both sides. So now that's our second one. Subtracted 20 from both sides. And then finally, if we're thinking about how did he go from 4x equals 68 to x equals 17, well, there's nothing in common on that. So we have to think about what happened. How do I solve for x? Well, the last step when I have a number multiplying a variable is to divide to get rid of that coefficient. So to get rid of that 4 divided by 4 is 1. That lets me solve 68 divided by 4 gives me 17, and that gives me my solution to my problem. So what did he do? He divided both sides by 4. Now I want to be careful. I don't want to say that he divided by 20. He didn't. I also don't want to say he multiplied by 4 because he definitely didn't. Because if I multiplied 68 by 4, I'd get a number much bigger than 17. So I have to say he divided both sides by 4. And then I will have filled in my blanks. But more importantly, we're thinking about the properties of equality, the things that we need to do to solve equations, remembering that whenever we're doing more than just simplifying, whenever we're adding to both sides, subtracting to both sides, we're using a property of equality to keep that equation balanced, to make sure that equation still stays worth the same on each side. That is our properties of equality.